Tutorial sheet 3, question 1. A 25 MHz carrier is modulated by a 400 Hz sine wave. If the carrier voltage is 4 volts and the maximum frequency deviation is 10 kHz, write the equation of this modulated wave for FM and PM. Here we're assuming that the modulation index is numerically identical. So if we pull out the bits of information that we need, we're given that the carrier frequency is equal to 25 MHz and the message frequency is equal to 400 Hz. The carrier voltage VC is 4 volts and the maximum frequency deviation is 10 kHz. So that's the information we're given. We're also told that the modulation index for the FM and the PM have to be identical. So if we write down the standard form for FM, what we get is a carrier voltage sine of omega CT plus beta sine omega M of t. And sine, it could be cosine, it doesn't really matter. So here we know that omega c is equal to 2 pi times 25 times 10 to the 6. If we work that out, we get 1.57 times 10 to the 8 radians per second. And omega m is equal to 2 pi times 400, which is equal to 2,513 radians per second. And our modulation index for FM is equal to the frequency deviation divided by the message frequency. And in our case we have 10,000 divided by 400, which is equal to 25. But that's equal to both for FM and PM. And the equation for FM and PM is exactly the same. The modulation index, the actual value of the modulation index is exactly the same in both cases. So the equation for a single sinusoid is exactly the same. So, well, we know VC is 4 volts. Sine, well, we know what omega c is now, 1.57 times 10 to the 8 t plus 25 sine of 2513 t volts. And that's also exactly the same for phase modulation.